All right, so that's number 2. And then number 3, using delta t equals 10, what's the value of r of delta t? Okay, so that's easy enough to do. Number 3, so r of 10, we can just go up here to our y1 of 20, copy it down, reviewing these calculator techniques, so y of 10. So now I know it's negative 2310.75 equals negative 2310.75. And it asks, how close is this to the limit value? So once again, I want to know what the absolute value of negative 2310.75. I'll condense the minus negative to plus 2193.75 is, and I can once again just go, this is already negative, so let's go plus 2193.75, and then just take the opposite of what I get here, so I'm going to get 117. All right. So that's how close we are to the limit value. If we take a smaller value of t, we are closer to the limit value. However, we're still not even within 100, right? We're off by 468, off by 117. So now this is the real crux of this, is we want to know if I wanted to get within a specific proximity, what value of delta t would I need? So suppose we want to be within 10 of the limit, what value of delta t would I need? All right, so the general process to do that, to find out what value of delta t I would need to be within 10 of the limit, is start with this inequality. Now I've got all these steps here, so I hope you've had an opportunity to try this following those steps, and just watch what I'm doing here, make sure you did it right, or if you get up to a certain point where you were stuck, then try to do it on your own from then. So we're starting by writing the inequality, so absolute value of r of delta t, just to give us a starting point, is less than 10. And basically we're going to solve this for r of delta t. So now we're going to substitute in step 2, r of delta t is negative 2193.75 minus 1.17 delta t squared, right? That's just because that's our expression for r of delta t. Just bringing it down from here. So that's why I can substitute that. And then I have minus L, and our L is negative 2193.75. Let's put this up here. Our L is negative 2193.75, because we're going to keep coming back to that. So minus negative 2193.75 is less than 10. All right, so you probably noticed right away that we can cancel the 2193.75s and just end up with absolute value of negative 1.17 delta t squared is less than 10. So you're going to often be dealing with absolute values in a lot of the work that we do, and one thing that you can look for is ways that we could drop that absolute value out of there, because they tend to be tricky to work with. So we know delta t squared is always positive. So if I have 1.17 delta t squared, that will always be a positive number. So that means that 1.17 delta t squared is the same as the absolute value of negative 1.17 delta t squared, because delta t squared is always positive. All right, so now the trick is to solve this inequality. So it's tempting to just do square root of both sides. That is incorrect. In this case, as you'll see later, if you just square root both sides, you will get the correct answer. Divide by 1.17 and square root both sides. But that's only because this particular function is a nice quadratic centered at delta t equals 0 is where the vertex is. And if it weren't, then that technique would not work. So you need to know generally, how do I solve an inequality involving a polynomial that's not linear? You have to isolate 0 on one side. And then we need to look at this quantity and say, when is this quantity a negative number? So there are two main ways to do that. We can do it by graphing, we can do it by sign chart. So I'm going to illustrate both of those methods next.